My name is Vic Trabucco, and in this video I'm going to talk about the use and function of a Polariscope in a glass studio. There's three important uses. The first one is to work out the most efficient annealing schedule possible, and the second one is to check if different glasses are compatible with each other, and the third, it can also be used during the glass making process. Now, I've been using a Polariscope for over 40 years, and it's been an important part of the studio. And this one is built with a 15-inch diagonal screen. It has 4 elements to create the screen itself. It has a stainless steel light box, and it uses an LED light bulb, which is replaceable. And it's also put together with wing nuts to make it easy to assemble. Many artists have never even used a Polariscope. There's probably a couple good reasons why. They may not be able to read the information on screen, or the high cost. A full color Polariscope like this online would probably cost between $600 and $700. As an artist, I've designed this for artists at a fraction of the cost. And I'll have some information and cost at the end of this video. In this segment, I'm going to show you what heavily strained glass looks like. This is a piece of borosilicate, and it was just heated up and cooled off in the air. You can actually see it's already fractured. And we're going to take a look at what that looks like, and then what a piece of 1/2-inch boro that's been annealed looks like, and you'll see the difference.
All right, this is an example of heavy strain. You can see how bright the colors are and how close and tight the pattern is. The edges are very sharp, and where the colors converge together, that's where it's going to crack. Versus this 1/2-inch glass that's totally annealed, the light just passes through it.
We're going to take a look at some of casted glass. These are some sculptures that I casted, and we'll see what they look like in the Polariscope.
This is an example of very light strain. You can see how soft the transition is between the blue and the magenta and a little bit of the yellow. This is about 1.5 inches thick, and this is totally acceptable as a well-annealed sculpture.
All right, let's look at some commercially annealed glass and see what that looks like in the Polariscope.
In this example of commercially annealed glass, you can see, again, there's a pattern. This would be considered light strain. You can see that the colors between the blue, the magenta, and the yellow is still a very soft transition. And this is acceptable in commercially annealed glass.
All right, this is an example of one of my borosilicate sculptures. And we're going to take a look at what they look like in the Polariscope.
In this seagull sculpture, you can see that there's very little, if any, strain at all in the glass. Now with the chest piece, I simply ran it up to the annealing temperature and held it there for 1/2 hour and turned the oven off. And you can see there's a light amount of strain, but it's still acceptable.
All right, in this segment, I'm going to show you what some of my paperweights look like in the Polariscope.
You can see in this paperweight that this is light strain. There's the soft transition between the blue, the magenta, and the yellow. Important note though is if you look at the leaves and the flowers, there's no rainbow effect between the colors and the crystal, showing that they are a perfect match.
In this segment, we're going to take a look at a piece of float glass, window glass, and see what that looks like in the Polariscope. And also a piece of optical glass that's finely annealed that I cut and ground and polished into this cube.
You can see in this example of float glass that there is no strain, the light passes right through it. Also with this optical glass, this is fine annealed. Again, there's no strain in it. And this is typical of optical glass that's used to be ground and polished into lenses.
In this segment, we're going to show you how to actually test colors. In the video, in the studio, you'll see me actually making this test piece. And what it is a 104 clear with 96 in the middle. And this was heated up in the torch, flattened, and annealed. and then we'll take a look and see what that looks like in the Polariscope. I also did a sample of a 104 clear and 104 color, and so we'll take a look at that as a comparison.
This is how you would make a sample in the torch to test out a color to see if they're compatible. Here I'm just heating up a small section of 104 clear and flattening it out. Then I'm going to use some 104 green. I know these already match, but I'm just going to show you what they look like in the Polariscope. So we heat up a section and put out a small amount on top. Then you heat it from the back and get it really soft so that you can push the color right into the crystal. I'll flatten it out a number of times to make sure that it's totally encased, and then I'll just melt that off, and there's your sample. You can see with this sample, this is 104 clear and 96 color, and you can see that because the difference in expansions, how severe the strain is. You see how sharp the edges of the color are and how bright the colors are. The transition between the blue and the yellow is very sharp, so this denotes a heavy strain. Probably if this glass was a lot thicker, the amount of color would probably crack the glass. Now you look at the 104 with the 104, you can see there's no strain in between the color and the base glass, the crystal. And they also did just a clear piece just to show you what it looks like when it's just annealed. This I included just to show you what a pull test is, and this is a way you can test out colors in a torch. You just use a small amount of color over a small amount of clear, or it could be a different color too, doesn't matter, just two opposing glasses. Then you heat them up evenly and pull them out to a real thin hair-like section. I'll do another pull just to show you what it looks like. And just heat up the section and then pull it out very thin. Hold it straight and then burn it off at the ends. You can see in this example that the orange and the clear have a curve to them. That's because the clear is 104 and the orange is 96. The one with the greatest expansion will be on the inside of the curve, and I'll show that in the next slide. The 104 green and the 104 clear, you can see it stayed relatively straight. And this is a way to determine if colors are compatible, but it's not quite as accurate as the Polariscope. You can see in this example that the 104 is on the inside of the curve, and the orange is a 96 on the outside. The color with the largest expansion will always be on the inside of the curve, so that can give you some information too. This is how you use the Polariscope in the studio. I'm just checking to see if there's any stress in this wing, and I see some at the joint at the base. So I'm going to reheat that area because that could potentially crack. So I'll drive some heat into the wing near the handle, and then I'll check it again to see if the stress is out. And it is. So now I can continue working on the wing without the danger of it cracking. So this is a great use of using a Polariscope in the studio. As you just saw, an evenly heated piece of glass put in the Polariscope has no strain in it. So this is an important note. When you finish a sculpture, there's no need to hold it at the annealing temperature for an excessive amount of time. In most cases, an hour is enough before you start your ramp down.
This is a piece of Steuben glass. I was a technical consultant for Steuben Glass in Corning, New York for about 3 years. And I actually designed and built polishing equipment that they use to polish about 60% of their production. So let's take a look at what their piece looks like in the Polariscope.
You can see in this vase that there is a light strain in the glass. This is pretty typical of a vase that has a heavy section attached to a thinner section of glass. I used this gob to the side as kind of a benchmark. It's about 1 inch thick and about 3 inches in diameter. And this is some glass that I bought like over 40 years ago. So it has been stable for many years. It came from an optical company, so I know that they're not going to send anything out that isn't right. So I've been using this as a benchmark. And you can see that, again, it has a gradual transition between the blue and the magenta and the yellow. Now, the only exception I would say is when you're fusing glass. Glass that's only like 6 millimeters thick and maybe, let's say, 8 by 10 inches in size, you want to have no strain at all in the glass because of the thickness of the glass. It doesn't have much strength at 6 millimeter, and that stress can sometimes be enough to crack the glass.
Let's talk about building an annealing profile. I'm going to talk about the 2 important factors in annealing glass, and that is the annealing point and the strain point. In most glasses, the strain point is about 50 or 60 degrees below the annealing point. But as a rule of thumb, I use 125 degrees. So going from the annealing point to the strain point, I'm actually getting through that zone no matter where it is. So 125 degrees is going to be our rule of thumb. And then I'm going to show you some charts and show you how we can build an annealing profile.
This chart, I have an example of annealing soft glass. I'm going to use 950 as kind of an average. It might not be the exact temperature you have for your glass, but this is a starting point. So 950 down to 825 is 125 degrees, and that's where you build your first ramp down. And depending on the controller you have, I have 2 different ones. One is set with hours, so you just put the 2 set points, 950 and 825 in 3 hours. Or if you have a controller that uses degrees per hour, you would simply put this 2 set points and use 42 degrees per hour, and that'll give you approximately the same amount of time, 3 hours. But with soft glass, you need a second step. And so we're going to go another 100 degrees from 825 to 725. And at this ramp, we're going to actually speed it up. So we're only going to use an hour and a half, or approximately 83 degrees per hour, and that'll give you an hour and a half ramp down time. Now, depending on the oven that you have, in most cases, getting down into the 700s, you can usually just turn the oven off, and that would be safe enough. Now, if you're going to be annealing glass that's several inches thick, that's 5, 6, 8 inches thick, well, then you're going to have to extend your annealing schedule. But I'm not going to cover that here. We're just going to use this for an average thickness of glass, between blown vessels and sculptural work that might be a couple inches in diameter or thickness, and then this will work out just fine for that. Here's a chart for borosilicate glass. The annealing point is 1067 and the strain point is 940. Again, we have 125 degrees below the annealing point to the strain point. And depending on your controller, once again, you can just put your 2 set points in and plug in the hours, 1, 2, 3 hours, whatever works out for your glass. And in this case, for 3 hours, you'd use 42 degrees per hour, and that would give you 3 hours. The thing about borosilicate is once you get down to the strain point, and the same with any glass, once you're below the strain point, you can't add or take away any strain. So you can cool down the glass as fast as possible as long as you don't thermoshock it. So especially with soft glass, you want to go through the second step. And you want to get it to slow down enough that you don't have thermoshock. But in most cases, with borosilicate, you can just shut it off once you're through the strain point. Now sometimes I'm asked, well, how do you find out if you have strain in glass if you're using opaque colors? Well, the simple solution for that is to make the object in clear glass and run your cycle. But once you start developing your profiles, you can just take a look at the object, and if it's similar to something else that you've done in the past, even if it is opaque, you should be able to pick out a annealing profile that'll work for that piece. How do we start an annealing profile? Well, the first step is I would follow my suggestion. When you finish a sculpture, take a look at it in a Polariscope before you put it in the annealer. If there's no strain in it, then I would start by holding it for about 1 hour at the annealing temperature. And then I would start the ramp down. And let's say it's anywhere from 1/2 inch to about 1 inch thick. I'd use about 2 to 3 hours between the annealing point and the strain point. And then the second step for soft glass, the 100 degrees, you can drop that rate a little at twice the speed. And then the next morning I would just check it in the Polariscope, and you'd have some information. If there's no strain in the glass, then you know you're on the right track. And you can slowly cut down the ramp time, just a few minutes at a time, maybe cut off maybe 5 or 10 minutes at a time, and to get to your most efficient annealing schedule. In this demonstration, I took a 1/2 inch annealed rod, and what I'm doing is putting pressure on it as I'm bending the glass, and you can see the strain building. You can see how tight the banding is. And so you can see how accurate a Polariscope is in showing stress in glass.